Okay, let's go one further. What if you don't really know the shape of demand? Okay, well, we're going to use this. Let's use this identity that we've defined before. The price firms receive plus the tax is equal to the price consumers receive. And let's say we have some generic supply function that's going to be a function of the price that firms receive. And we also have a generic demand function that's a function of the price consumers receive. And they are no longer straight lines. They can be as crazy as we want as long as they exhibit increasing and decreasing things. Okay. All right. What happens to the price? What happens to the price of the firm pays and the price consumers? What happens to the price firms receive and the price consumers pay when we impose a tax? So we know that supply equals demand at any equilibrium. So let's start with this condition. Next up, we know that PF plus T is equal to PC. So let's put everything in terms of PF. We're going to substitute out PC and write PF plus T in there. All right. How does the price change when we change taxes? Right now you can think of the tax is at 0, or it could be at any value. And if we're going to increment it up a little bit, what happens to the price? What we really want to know is the derivative of the price PF with respect to the tax. And it turns out we can use this equation to find out that answer. It's maybe not as simple as just taking the derivative of PF equal to PT, but we'll get there, okay? So let's take the derivative of all these terms on both sides with respect to the tax rate. And then eventually we're going to use that to get this answer. So if we want to take the derivative of something with a function with respect to some variable t, we have to use the chain rule. First, we take the derivative of the quantity supplied. So we're going to, instead of writing S, this is all equal to the quantity supplied. This is all equal to the quantity demanded. Let's use this notation. So the derivative of this with respect to t is the derivative of the quantity supplied with respect to the price firms receive, because that's the inner variable. And then since this is the chain rule, this price that firms receive can change when we change the taxes. As we just saw in our last example, when you raised the tax from 0 to 1, the price firms received changed. It fell. Okay? So this is the correct way to write this. And this is, since we're doing the same operation on both sides, we can take the derivative on both sides. Okay. Now on this side, we have the derivative of QD with respect to PF, but then the derivative of the term inside brackets, if we're doing the chain rule, is got two parts. We have to take the derivative of this with respect to the tax and the derivative of that with respect to the tax. I realize I'm throwing around the word chain rule. As a reminder, if you have a function like this, g of f of x, and you want to take the derivative of it with respect to x, is going to give you the derivative of g of x times f of x times the derivative of the thing inside. And that's what we're doing down here. Okay, so this looks like a mess, but notice that we have that in there, and it's over here too. That's the thing we want, so we're going to solve for this. Okay, so let's group all of the examples of this partial derivative of PF with respect to t on all the same sides. That's the first one there, and now I'm going to subtract this term here. So I multiply that through and I end up with this. And this is equal to what's left over here, which is the partial derivative of QD over the partial derivative of PF. Notice this is the term we want here, these guys, so let's factor them out since they appear twice. And we have the partial derivative of PF with respect to t times the partial derivative of QS with respect to PF minus the partial derivative of QD with respect to PF. And that's equal to. Okay, and now let's solve for this little PF explicitly by dividing by this big term in parentheses. And we're going to get that the change in the price firms receive divided by the change in the tax is equal to this derivative divided by this thing. Now you might think we are really none the wiser here. We're just confused. What have we really learned? But we're gonna get somewhere. Trust me. So let's begin by assuming that we're gonna start at tax t equals 0. Okay. So we're going to start at the point where these prices are equal to each other and are just equal to the price. And then what this is going to tell us now is if you have no tax and then you impose a small tax, like you go from t equals 0 to t equals 0.01 to, increase it a little bit, how does that begin to change these prices? Okay. So one thing that's kind of useful is that we can now, since we're at this point where we're at the point where PF is equal to PC is equal to P, we can now say like, all right, well, the derivative of the supply with respect to a change in the price PF, we can just rewrite that as how supply changes when you change the price, because the price is PC or PF. And let's do the same thing with demand. How does demand change when you change the price PF? Well, at the point where PF is equal to PC is equal to P, we can just say this, like this works at this point here. And that lets us write this as such: the change in quantity demanded when you change the price divided by the change in quantity supplied when you change the price minus the slope of the demand curve when you change the price. And here's where we can get creative. Let's multiply both of these now by P over Q divided by P over Q. This is allowed because these cancel out to 1. And notice that at the point where P, QD is equal to QS is also equal to Q whenever the market clears. So we can say that, here, I'm going to write this a little bit bigger. The change in the price firms receive when you impose a tax is equal to the change in the quantity demanded, the slope of that line, times P over Q. But since Q is equal to QD, let's change that to QD, divided by the slope of the supply curve when you change the price, times, since we're multiplying by P over Q on the denominator, we can say divided by P over Q. And since Q is equal to QS, let's change this to QS, minus the slope of the demand curve with respect to P times P over Q. But since Q is equal to QD, let's change that to a D. And the reason this is useful to write is because these are all elasticities. The change in price a firm receives when you change the tax is equal to the elasticity of demand. This is, if we're going to define the elasticity to be always positive, then this is negative, divided by the elasticity of supply, which is positive, plus the elasticity of demand. This term here is going to basically be, the change in the price is determined by the size of the elasticities, okay? And since we've defined elasticity to sort of always be this positive term, then we need to, like if we have a negative sign in front of it, this is going to be less than 0. Price firms receive falls as t goes up. Okay? So how does the price a firm receives change as you change the tax? It goes up. The amount it goes up, it depends on the elasticity of demand and supply. Let's go one further and now see what happens to the price consumers pay when we change the tax. We don't actually have to go through all of that work again because we know that PC is equal to PF plus T. So if we're going to take the derivative of both sides of these with respect to T, then we're going to get that the derivative of PC with respect to T is equal to the derivative of PF with respect to T plus 1. Okay? And we found that this term here is given by this. So this is equal to negative ED over elasticity of S plus elasticity of D. And if we're going to add 1 to that, one way we can do that is like so. And then we're going to get the equation that we want. The elasticity of PC with respect to T is equal to the elasticity of supply divided by the elasticity of supply plus the elasticity of demand. And I'll rewrite this one over here. The elasticity of demand over the elasticity of supply plus the elasticity of demand. This thing is greater than 0. This thing is less than 0. So the price firms receive goes down when a tax gets imposed. The price consumers pay goes up. Not surprising. But notice that they each depend on the elasticities in this kind of important way. And the easiest way to see is sort of imagine the extreme case. If ES, the elasticity of supply, goes to infinity, that's the case where ED is equal to some constant, so something not infinity. That means that supply is really elastic and demand is comparatively inelastic. Well, if that's the case, then this thing is equal to 1 because infinity divided by infinity is 1. Okay? And this thing over here is equal to 0 because any number divided by infinity, unless it's infinity, is equal to 0. So what does that say? Well, as the elasticity goes to infinity, as the elasticity of supply goes to infinity, the amount consumers pay of the tax goes towards 1. So let's draw a little picture to illustrate that. So here's demand, and if supply goes totally flat, that's an infinite elasticity. Then if you impose a tax, the entire tax is paid by consumers. Okay? In this case, the supply curve cannot go down at all. So the price firms receive never goes down. Basically, if they can supply it at this price, they'll supply as much as you want. Any lower, they won't supply it at all. So in this case, 100% of the tax goes to the consumer, and we can see that through here. Conversely, if the elasticity of demand goes to infinity and the elasticity of supply is some constant number, then the price change with respect to the price consumers pay, the derivative of that with respect to taxes, this is going to be ES, which is constant, divided by some infinity, so that's going to be 0. And this term over here is going to be equal to 1 because we're going to have an infinity over an infinity again. That situation looks something like this. So now demand is horizontal, supply is not. So if you impose a tax, it falls entirely on the consumers, because if you raise the price even a penny for consumers, demand collapses to 0 and the market shuts down. So all of the cost is borne by firms in that case. And in the intermediate case, basically what this shows us is that whoever has the less elastic demand is the one who bears the greater share of the tax. They bear more tax burden. And this is basically the idea of what's called tax incidence. So who pays for a tax doesn't really have anything to do with who's legally obligated to pay it. it has everything to do with the elasticity of supply and demand. And the elasticity of supply and demand are ways of saying, how flexible are you to respond to price signals? Okay. And whoever is not flexible is going to basically have to entirely adjust by allowing their price to adjust. If your quantity is fixed, then when a tax comes in, it just changes your price. On the other hand, if your quantity is very flexible and your price sensitivity is high, then a tax will greatly change the quantity, but not have much of an impact on the price.